All right, so our final perspective is going to be given by Sarah Ruth from the Office of Polar Programs and Directorate for Geosciences. And take it away, Sarah.
Thank you very much. Firstly, yeah, it's a great pleasure to be here. I have not had a lot of familiarity with this work within NASA, and it was a great opportunity to, as I just from the previous speakers, to learn about all of this and think about the parallels with what we've been doing in the Antarctic for the last 70-something years. So my name's Sarah Ruth. I'm the section head for Antarctic Sciences in the NSF Office of Polar Programs. NSF manages and operates the US presence in Antarctica, and I look after the science, or I support the science side, and I have plenty of colleagues also who look after the logistics and the infrastructure. So very much a team effort, but I'm going to be taking a slightly science-focused look at what we do in the Antarctic, and particularly in our McMurdo station. Next slide, please. Thank you. So everybody in the world operates in the Antarctic subject to the Antarctic Treaty System. The US was one of 12 original countries that signed it. It's now grown to, that should say, 56 members nations. It was signed back in the 50s, I think, when it sounds like an awful lot was happening around the world in science and exploration. The key features of it are that the Antarctic really can only be used for peaceful and primarily scientific purposes. We're all there by mutual consent. So there are some historical legacy kind of arrangements. So you'll see that the colors indicate different countries have primarily operated in different parts of the Antarctic. But actually, under the agreement, under the treaty, all territorial claims are held. You can't make new claims and you can't dispute other people's claims. The consensus is implemented through domestic law. And so that's how we've found ourselves with the NSF managing the Antarctic science programs, or the Antarctic programs. Next slide, please. I think we missed one. There should be one there. So under a presidential memorandum from 1992, I believe, that restates the US's commitment to operating 3 year-round Antarctic stations. And those are our Palmer Station, which is up on the top left of that picture, on what we call the peninsula, that mostly hosts shipborne operations and marine applications. We then have our main station, McMurdo, which is the lower of the three, and that's in the Ross Sea enclave. And then at the center we have the South Pole, and the US is the only station, the only country that operates a station at the South Pole. Next slide, please. This shows how it's all connected. Most of our operations are run out of the continental US. You get to the peninsula by getting down via South and Central America, and then jumping off at Punta Arenas and sailing down to Palmer. The other main route in goes via Christchurch in New Zealand. You'd get to there, you then go directly from there to McMurdo Station, and then that serves as essentially our base camp for South Pole Station. There's no way to get to South Pole direct. Next slide, please. And when you're at McMurdo, these are some of the transport options you'll see. Those are the Air National Guard operated skied C-130s. Those will get you in and out of McMurdo. We have other aircraft that will do that, but it's those heavy lift type aircraft. Operations from McMurdo are supported by smaller aircraft or by some helicopters that we also run. Those will take you to the nearest field sites. If you want to go to South Pole, you can fly in one of the C-130s, or we operate what we call a South Pole overland traverse is the main way of doing that. That also supports some science operations via that route, but typically that's the way that we're shifting a lot of cargo to the South Pole. It's about nearly 1,000 miles and takes over 30 days to do that, but it's actually our most cost-effective way of getting things to and from the South Pole. And then cargo comes in via large container ships that also delivered to that deliver their cargo to McMurdo. Next slide, please. So a brief history of McMurdo Station. We're on Ross Island, which was named after James Clark Ross in 1841. He didn't land on it, but he found it. It was then used, that whole area was used as a base for whaling, sealing, and polar exploration. We still have an original hut from Scott and Shackleton's parties down there, and there are a couple more nearby. Big time infrastructure began with the US Navy in 1955 to 56. They built a very large port there. As you can see, it came in from ships and in the form of boxes on sleds and things. It grew very organically over the next few decades. Milestones in its history, it became recognized as a potential use by scientists in 1957-58 during International Geospatial Geophysical Year. The US Antarctic Research Program, which is our predecessor program, was founded on the back of that in 1959. After the Antarctic Treaty came into effect in 1961, that really solidified its use for primarily scientific purposes. And partly as a natural consequence of that, it's been managed by the National Science Foundation since 1970. Next slide, please. So this is what it looks like today, pretty much. And I've just put some arrows showing some approximate locations of the kinds of things you'll experience there as a scientist. We have lodgings for up to about 1,000 people. Currently, we obviously have all the usual support services you'd expect, food, medical. We have an infrastructure that supports our scientists who arrive there. They get their tents and their equipment, their vehicles, that kind of thing. And we also, at the center of this, you can see there's a very large laboratory and engineering and kind of office complex that again almost entirely supports science. And then we have all the usual supporting infrastructure for waste, environmental, pretty much anything you want to do down there. That's all has to be done, has to be brought in by sea or air and then supported there. Next slide, please. Within Antarctic Sciences, we are guided by some decadal priorities that get renewed periodically, but our current ones are consistent with the NSF mission that we maintain a core program of investigator-driven research, and that covers a wide range of disciplines in that area. And then there are some overarching themes that we were also encouraged to prioritize, which are around sea level rise, obviously really critical questions around climate change. How are the organisms, the biota down there, how are they evolving in relation to their environment and changing to that environment? And then we also support a lot of astrophysics and other sort of telescope-based work, mostly at the South Pole. And our overarching criterion is that you should be down there because that's the best or the only place that you can do your research. Next slide, please. And we periodically undertake major reviews to look at either the whole of our research programs or particular aspects of them. For instance, we just took a look at Antarctic and Southern Ocean research, what our priorities should be going forward, both on the logistics side and the research side. Next slide, please. Within our section, we have 8 programs that really represent the breadth of the science that we have, that we support. So everything from a lot of ground-based and so earth sciences and glaciology at the ground level. We have a cyber infrastructure program. We have our biology programs, and then oceans and atmospheres, geospace, particularly at McMurdo. So upper atmosphere, and then we have education and general facilities programs. Being NSF, we solicit proposals from the research community and conduct peer review. So that's the primary way that we identify the science to support and prioritize what we're going to fund. But we do also work with other agencies, including NASA, who have long-term programs down there as well. Next slide, please. So some of that, although in a way it's opportunistic because we're at McMurdo because that's our base and it's historically our largest operation, but you can do a great deal of science while being based at McMurdo. And so that main picture shows the dry valleys. It's a field camp in the dry valleys. These are about 1,000 kilometers outside of McMurdo. You typically get there by helicopter. It's a very remote, it's one of the driest and coldest environments on Earth, one of the most isolated. It's an incredibly rich research environment. Does have some parallels with other planets, particularly Mars, and in the way that it's the way that it is established, I guess you can say. You know, it again being very dry, very isolated, has a lot of underground processes, some biological processes and things to study. Very little water, but there is some. And all of it's amazingly interesting to study. We have been supporting activities down there continuously through our long-term ecological research program since 1992. Then just moving clockwise, we have a volcano, an active volcano right near McMurdo. So a lot of work goes into studying that. It's the southernmost active volcano that you can access and very interesting for that. The next picture down shows, because everything is very remote, we are funding some interesting technical work, some interesting technology developments, and that shows a project from MIT, which involves actually just dropping sensors into the ground from a height, because it's really just too hard to keep sending people out to these remote locations and to monitor and to place monitoring equipment. And so this is a rather inventive way of getting to those locations and actually dropping these things from a height, and then they penetrate into the ground, and they can tell you a lot about seismology and the ways that the ice is shifting and that kind of thing. And then the final one is a mobile laboratory that can be deployed. That's actually a DOE atmospheric radiation measurement facility. We had a big one down at McMurdo for a while. That all arrived in boxes and again can just be set up, and it can look into the atmosphere. It's looking at things like clouds and aerosol. It has LiDARs, radars, all kinds of things. So again, we try to be as versatile as we can, because maintaining long-term camps in these slightly further out locations is really very challenging because of the logistics that we have to deal with. Last slide, please. And finally, back to that big lab in the center of the McMurdo picture. This is built in across several levels, as you can see, and that really houses all of the science that you can do once you bring it back to the base. So we have there a lot of laboratories, engineering shops, we have storage for ice cores, and we have things like libraries and educational facilities and offices. So again, pretty much that's ground zero for all of the work that we do from McMurdo. And in the foreground, you can see our helicopter fleet as well. So it's an amazing environment to work in. And so with that, I'll stop. I think I've hopefully just about made up some time, and thank you.